great head. Looks awful because it's not a Windows operating system, so please be patient. Alright, good morning, ladies and gentlemen. First of all, I'd like to say thank you for giving me this opportunity to present my research work and to share ideas with all of you. Let me start by introducing myself. I'm a first-year PhD student of University College Cork. I'm currently working on a pervasive healthcare project called CARA, C-A-R-A. The word CARA is an Irish word, means friendly, and my job is focused on the software design part. The topic I'm going to present today is a web-based, context-aware, real-time assistant remote monitoring system, especially designed for pervasive healthcare. I've divided my talk into 4 parts. At first, I will give you a brief introduction on pervasive healthcare. Next, we will go through the system design overview. After that, I will provide you a few case studies of using the CARA system. And in the end of my presentation, I will show you a short demo video. Hopefully it works. I don't know. See, we don't have the graph here. But it's fine. To begin with, I'd like to talk about some issues of aging society. As we all know, the problem of aging society has concerned more and more people. The first graph actually shows how fast the senior population increased in UK and the USA over the last 10 years. And the senior citizens are requiring more medical care than the rest of the population. The second graph shows the increase has a direct impact on the healthcare cost. So as a result, the healthcare system has become a national challenge. Well, recently, research proves that pervasive healthcare has the potential to reduce the long-term healthcare expenses and improve the quality of healthcare services. It also supports the desire for individual living and at-home care. Then what is pervasive healthcare? The notation of pervasive healthcare presents us with a major shift from the traditional clinic setting to a home-centered setting. The development of the wireless sensor networks and the web technologies can improve the communication among patients and the caregivers. It enables the delivery of accurate medical information anytime, anywhere. Alright, let's move on to the main subject of my presentation. The CARA system is designed to provide a real-time, intelligent, at-home pervasive healthcare solution. As the universal access makes the internet a very ideal tool for remote monitoring applications. But while in traditional web application, there's a limit to the interactivity that can be added into a single web page. So our approach is to develop the CARA system as a rich internet application, which allows the real-time user interaction. The client application is implemented by the Adobe Flex. The only tool required for running it is a web browser with Flash, Adobe Flash installed, which means the CARA system is accessible from any computer or any suitable smart devices, such as a PDA or smartphones. Alright. Since the client application is a Flash application, it is compatible with different operating systems and web browsers. This graph is awkward, but you can guess we test our application on Windows, Mac OS, and Android and Linux with different web browsers such as Internet Explorer, Google Chrome, some Safari and the Firefox, so on. But unfortunately, the iOS doesn't support Adobe Flash yet, so maybe later. This graph also. Okay, let's take a look at what makes up the Kara system. Basically, there are 4 components in the system. The first one is body area network. As a key component of the system, the body area network includes the wearable wireless sensors such as ECG, oximeter, temperature, accelerometer, and the gyroscope sensors. These sensors and the firmware are developed by Tyndall National Institute of University College Cork. The second part is remote monitoring system. It is responsible for remotely controlling the body area network and continuously monitoring the patient's vital signs. A web camera is integrated to this system, which allows the interaction between the patient and the caregiver. The third part is data review system. It is designed for the medical consultant to review the sensor data previously collected from the patient, just in case they might be not available for real-time monitoring. The system not only can present the sensor data in a graphic flash chart, it also allows the consultant to review the recorded video with the synchronized sensor data. The last but not least part is healthcare reasoning system. The reasoning system is implemented by a Windows workflow rule engine. It applies medical rules to the real-time data received from the patient. Recently, we have developed a movement monitoring function. Since the reasoning system is still under developing, we will not go through it in detail today. This is the architecture of the Kara system. Don't know if we can see it clearly. I'll try to explain it. As you can see here, the patient's vital signs are monitored by different types of sensors within a body area network. And all measurement data gathered by a base station are transmitted to a personal gateway, also referred as a patient client, through a wireless connection. The data then are transferred to the server side over internet. A problem with all wearable wireless sensors is the noise of the signal. To improve that, our solution is to integrate a FaceTime function into the system so that the remote medical consultant can distinguish the bad readings from the magnificent readings. To achieve that, the Flash application running on the patient's client publishes real-time sensor data along with the live video streams to the Kara server. Then the remote medical client can request a connection with the patient. Once the connection is established, the system will provide the medical consultant with continually updating views of the real-time sensor readings. In the meantime, the remote section is recorded on the server, so the medical consultant can review it and analyze it anytime later. The Kara system can be used in different ways, from fully automatic monitoring of patients' vital signs to use as a non-automatic assistant for remote consultation by a medical consultant. In the next few minutes, I will show you 3 scenarios of using the Kara system. Although the full automatic system is our final goal, it is recognized that current practice and the user requirements may differ from our automatic goal. Since the healthcare is more than just using the most advanced technologies, so we have built a solution that focuses on an incremental introduction of the Kara system as a pervasive healthcare application. So this solution supports our first scenario here, where the wireless sensors are initially introduced to the patient in the clinic under the supervision of a nurse or health caregivers. And then in the meantime, the real-time monitoring is carried out by a remote medical consultant. This use of the system provides a very acceptable starting point for both patient and the caregivers. The second scenario involves real-time remote at-home monitoring without supervision. Again, there are real-time sensor data and live video streams for the remote caregiver. In this case, the caregiver can either be a medical consultant or a nurse instead. The patient is monitored at their home, so they have a live view of the remote medical caregivers. So this is also a very important part for the patient to get used to these top technologies. They are two-way video links, so it's better to get used to it. Since the internet access becomes more and more available today, it turns out this application is a very convenient and effective tool for the medical consultant to carry out the health care. The last one is remote healthcare data review scenario. It is very convenient for the caregiver to be able to record the monitoring section and review it and analyze it anytime later. The data review system supporting this scenario includes sensor data review and video replay functions. The sensor data review function allows the medical consultant to analyze all context of the real-time sensor readings. It shows the recorded sensor data in a graphic flash chart. And the video replay function is designed for the medical consultant to review the recorded video section for the patient with associated sensor data. It is developed based on the real-time remote monitoring application. Every time the patient's live video is published, it also records it as a flash video on the server for the caregiver to review. To finish my presentation, I will give you a vivid view of the Kara system. I want to show you a short demo video.